Well, question 8 is all about functions, relations, graphs. This is the question you're going to get things and completing the square linear programming, functions, inverse functions. You could get some coordinate geometry even. So anything with parallel lines, perpendicular lines, everything, coordinate geometry. You could get some algebra sneaking in here, like some tough simultaneous equations. And question 8 is usually one of the more we reach into the beginning, and maths split in two sections, either 1 to 7 and either 8 to 10. So this is 3 questions, 8, 9, and 10, and this is 1, 2, 3, 4, 5, 6, 7. So that is two sections, section 1, section 2, and this is usually the hardest. Well, it is the hardest section. And the first question out of the hardest section is the most unpredictable, because there are a wide range of topics that could come from relation functions, graphs, coordinate geometry, and algebra. There are a wide range of topics that will come there. In question 9 and question 10, these are more predictable. This is geometry and trigonometry, so circle geometry and some bearings or some kind of thing. And this is vectors and matrices, also very predictable. Tough, but predictable. So number 8 is usually where students lose most of the marks. So let's do a bunch of number 8s and see if we can strengthen ourselves as far as that is concerned. Remember, I'll be doing a 12-hour session this Saturday, so I can arrange my sleep for that 12-hour session this Saturday with myself and teachers from the Student Hub. One other teacher from the Student Hub will be doing a 12-hour session starting from 12 midday to 12 in the night. So if you're interested in that, you know the drill. You WhatsApp the number and you jump in on that crash course, right? It's gonna be a night to remember. So using the quadratic formula, show that the roots of the quadratic equation, this that. So let me see if I can put a little extra page in between here, boy. And the equation was 25x squared minus 30x plus 7. 25 there, 25x squared minus 30x plus 7. That's the equation of the quadratic equation. That's the equation of the quadratic equation. And what is the quadratic formula? So the quadratic formula is x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So that's your quadratic formula. Minus b plus or minus the square root of b squared. Hey, Marissa, you know anything? You know anything? So okay. That's it there. So we want to apply this formula using this, where a is 25, b is negative 30, and c is 7. Therefore, x is equal to minus b, so that's 30 plus or minus the square root of b squared minus 4ac all over 2 by a. And this boils down to 30 plus or minus the square root. What goes in the brackets there? Over 50. So if I have 900 minus 4 by 25 it's 900 minus 700. So 4 by 25 is 100. 900 minus 700, 200. So what we could deduce from this so far, boy? Let's see what we're aiming towards. So we are aiming towards x is 1/5 3 plus or minus x is equal to 1/5 of 3 plus or minus the square root of 2. So it looks a little scary, but we should be able to get down. Should probably be able to bring out a little something out of this here. Because watch this, ladies and gentlemen. You can put it in your calculator, and your calculator might show you, give you some hints. Your calculator might show you some hints. So if I do 30 plus or minus the square root of 200 is actually the square root of 100 multiplied by the square root of 2. That's you could do them thing. You could do them thing. Just trust me on that one. Nice suits, right? So what is I trying to say here, boy? The square root of 100 is 10. The square root of 100 is 10. So this is 30 plus or minus 10 root 2 over 50. And since everybody could give me a 10, everybody could spare me a 10. I could say 10 into this 1, 10 into this 5, 10 into this 3. I will end up with, can you visualize this? I will end up with 3 plus or minus the square root of 2 over 5, which is the same as if I took out the 1/5 instead. I took out the 1/5, so it was 1/5 into 3 plus or minus the square root of 2, which is QE. Rate out of 10, how much you understand that now? The speed I'll be moving at wouldn't be too nice for people who now learning how to do these things, but it's good speed to get as much done. And so otherwise, solve the following pair of simultaneous equations. What? So they want me to solve these following pair of simultaneous equations. Well, this is non-linear because you have an x multiplied by a y here. So you can't use your elimination method the classical way. And this is linear. So what you know about solving simultaneous equations, if one is linear and the other one is nonlinear, if that happens, you need to substitute. Best method is substitution. So we have y is equal to 5x minus 6, that's equation 1. And 5xy is equal to negative 7. Let's call that equation 2. And if we substitute for y in equation 2, or basically substitute equation 1 in equation 2, we'll get 5x into, instead of y is really what? If you watch here, y is really 5x minus 6. So I can take this 5x minus 6, which is y, and replace this y with it. So I'll get 5x minus 6 is equal to negative 7. And 5x by 5x is 25x squared. 5x by negative 6 is negative 30x is equal to negative 7. And then you get 25x squared minus 30x plus 7 is equal to 0. And where have we seen this before? Where have we seen this before? In the first part of the question. In the first part of the question, we deduced that therefore, this is really x is equal to 1/5 of 3 plus or minus the square root of 2. So x is really equal to whatever that is. What are we to do for this? They want me to get numbers in decimals or something? Where they want me to take this? So x can either be equal to that, which is a number. We can get that into decimals. I don't think they want you to substitute this into that. That might be the add maths way. But for normal maths, let's just get whatever that number is. What is that number? What's that number? 1. So you see that little trick where they say hence? Anytime you see that word hence, breathe it in and say, all right, so they use what was given before. So what was given before is indicated by the use of the word hence. Again, 0.883. So you can say maybe 4 significant figures, 0.828 or so. And then substitute for y, for x in equation 1. I change it's plus or minus, right? But I use the plus first. So x1 is that, and we substitute in for x1. Y would be equal to, it's not negative, and it's 1 is positive and 1 is negative. It's 2 x's. So y is equal to 5 by that number, 0.8828 minus 6. Which is negative 1.586 thereabouts. So that's one solution, and the other solution, because it's 2 values of x, 2 values of y. Y'all understand? Let me just make this a little smaller, and he can go in the corner, so I can get some space now. So this is one solution. One solution is 0.8828 comma negative 1.586. And another solution, x2 could be 1/5, and this time instead of using the positive, I use the negative. So let me just go back up in this and change this positive to a negative. My calculator in my hand here, people. That's what I'm dealing with right now. Tell me for that you'll get 0.317, 0.3171, and substitute. Therefore, y would be equal to 5 by 0.3171 minus 6, 5 by dot boy, minus 6 boy is negative 4.414. Yeah, I'll get them thing. Why isn't each other to figure this? So the next solution is 0.3171, comma, negative 4.414. That's the solutions for the simultaneous equation there. Wow, what a question. Question from question land. If that kind of simultaneous equation blew your mind, that's because you didn't revise the last thing in simultaneous equations, which is solving a system of simultaneous equations when one of them is linear and one is nonlinear, this comes in this part of the question, right? So let's go on. Let's see if I can sneak in another slide because this question have long pants. Let me see if we could do a next part of this question. Where this question is going. So slide 3 is just one big blank page right now because I'm trying to find the question. There it is. Y'all should be seeing that now. Consider the function y is equal to 2x minus 3 for integer values of x, blah, 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 blah. Complete the table above for the missing values of y. Okay. And draw the graph y. Graph to draw. So consider. All right. So we need to substitute. Let's just do this real fast to get the missing values. So y is equal to 2x minus 3 when x is negative 1, y would be equal to 2 by negative 1 minus 3. Again, the missing values are the negative 2 minus 3. Negative 5 will go in there. When x is equal to 2, y would be equal to 2 by 2 minus 3. That's 4 minus 3. Big yawn. 4 minus 3 is 1. And it seems like it's going up by, and that seems like a good number because it seems like all the values here are going up by 2. Right, true. Linear now. 2 is the gradient. So every time you increase the value of x by 1, it's going up by 2. All right, 3 marks. We don't get a bang, bang. So draw the graph. Use the graph to determine the value of x when struggles. Let me talk to myself and see if I really feeling to draw that graph. When you're feeling to draw that graph right now, boy. All right. Bring up the graph paper for me on slide 40. Let me draw the graph. Wait, slide 4 has not been yet created. There it is. Yeah. So bring up that graph paper there. And let me see what we can do for the people then. So this is easy man thing, you know. You're supposed to know this. You just take them points and drop a little graph for the people them. And very long really. I'm still depressed from that loss. I don't say depressed. Depressed is such a dramatic word. Golden State playing again today, boy. We had to win this game today, boy. Oh, jeez. Now the graph you get for CXE wouldn't look like this graph paper, right? It have a little different look, but you're still getting to see the graph concepts here. Pretend this part of the graph page don't exist. I might use all of that. My graph might come out a little flat too, but it's for the people. It's for the people just to get the gist of what to do. So what I do every time I draw a graph is see how much space I need now. So the x going down to -1 and going up to 4. You see now, -1 all the way to 4. So I don't know. I need a little smooch day, -1, and I need all the way up to 4. All the way up to 4. So you see, -1, 4, and then the y going from -5 to 5. So it means I need to go down to reach -5, and that's the first way, first thing you start off with a graph now. And sometimes you want to watch down to see if you need to do any other wildness when f of x is 2.2, so that's a wrong way. All right, so now we could draw the graph. We know the graph will fit within that little allotted frame there now. So we're going back to this slide here now. And I might draw a line right here, so drawing graphs on a Wednesday is the best thing in life. There's nothing else that can bring more happiness than drawing maths graphs on a Wednesday, right? And then we will want a little, how much you going up to? 4? I forget already, 4. So let me get each one like that. Remember, you'll have a different scale in the exam, right? The scale is a 5, 10 kind of vibe scale now, boy. So this is just to give you a gist of it, but you want to practice with the scale that you have for CXC. So this is 1, 2. By the scale, I mean we already grid organized for CXC now, 4, 5. And your people wouldn't be in this, what is called this landscape, it would be portrait. And I want a little negative 1, 2, bro. And then this going out to 5, 1, 2. Struggles in life. 1, 2, 3, 4, 5. Let me make a little 6 to make the thing look good. I can't even get to write negative 5, boy. They're just fighting me down here, boy. Negative 3, negative 2, negative 1, balance 0 there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Ready for them. Label the axes. X and Y. X and Y. They gave us a scale. They gave us a scale, right? See that? I wish I had. For the next year, people who watching this next year, when I'm doing this next year, I'll print out the CXC graph page so I can use that with the overhead camera, right? But for now, I had to use a little imagination. So to draw this scale, I would have set 2 centimeters to be 1 unit, and it would have worked out nice. It would have worked out real nice. Hold up. I'll give me 2 minutes to get a graph page print, so I'll have to wait till next year. All right. Let me go and tell them to print the graph page and thing, right? So 2 minutes. So this is tough company. So. How are you looking there, people? Are they seeing? I'll be back. This is my point. It's not looking like I see the point. Kind of have to see the graph. Part of the graph, just looking at a blank page.
I got it.
It's not a blank page. There's actually lines on it.
You drop it lower.
Yeah. Drop it lower and just trying to set this up to get the graph to look like the graph can be here. See. Come up with the mic. All kind of thing here, boy. Alright, I should do it. I got it. Lower, there is the one thing I show, average, the one thing I show. So CSEC graph page. CSEC graph page like this one. Right? There you go. How much people are they like? Still I got left here. Well, CSEC graph page kind of like this. So I say that 5 graph page. Just see me example. 5 blocks like that. And each one of them blocks supposed to be a centimeter. Now mine is not a centimeter because I just print this thing back. Right? So each one of them blocks supposed to be a centimeter. And in the question, you get a picture what? In the question, here, they said 2 centimeters for 1 unit on the x-axis, 1 centimeter for 1 unit on the y-axis, 2 centimeters for 1 unit on the x-axis. And the x-axis went from -1 to 4. So on my paper, paper 2 centimeters for 1 would be like, all right, every 2 blocks is 1, and this is going to be 0, so this is going to be -1 there. 1, 2, 3, 4, and I think there's going to be up to 4, right? And then on the y-axis, 1 centimeter for 1, so this is -1, -2, -3, -4. So that's what I'm going to do here real quick, and I'll just stand my fraction. So you're going to see lines that I draw pretty easily. The lines will show up. So that's that. Make this yes. So when they give you a scale, that's I realize this. So their scale was 2 centimeters. Let's say this is 1 centimeter, right? 2 centimeters. You see, so that's 1 centimeter. So 2 centimeters for 1 on the x-axis, right? I'm not mistaken. Yes, 2 centimeters for 1 unit. So this is 0. This is 1, 2. Everybody understand the graph now? 2, 3, 4. Understand how graphs should be graphed? And then this will be -1, -2, negative 3. Oh, negative 3 was true. That's okay. Negative 3. Negative 4. Why isn't each other catching that? It might get extremely low now. You're hearing me clearly? Should be hearing me clearly. Just double check I come through right away. Mistake and mistake. A distracted. Remember, this is the x every centimeter was supposed to be 1, and the y, sorry, every centimeter was supposed to be 1. So we write negative 1, negative 2, negative 3. Good? Are you good?
This not showing up.
Negative 4. Ah! And here, mess off. Negative 5. Real trouble with this street, buddy. Get you? So, they should be in it now. Y'all hearing me good now? Sorry about the trouble in this stream. So, yeah, we have 1, 2, 3, 4, 5. And then negative 1, negative 2, negative 3, negative 4, negative 5. And I think that's the day. I think I should understand everything about this now. So everything about this making sense. What I'm saying is the scale that I wanted, and you usually write your scale right here in your diagram, right? So you write scale, and then you write x-axis, and the scale that they wanted is 2 centimeters equal 1 unit on the x-axis, and on the y-axis, they wanted 1 centimeter equal 1 unit. And that's what I have here. If we were to suppose that each one of these blocks are centimeters, and that's what it usually is in CXC, then this is 2 centimeters, 1 unit. Catch it? That's the scale. That's it. That's it for these graphs. The next graph, I mightn't take my time and do all of this, right? It's just, I really wanted to show you all how the graph page looks here. You wouldn't feel frightened when you're reaching the exam. And let's go back to the graph here. So negative 1, negative 5 is a point. Then 0, negative 3. And it's a straight line. 1, negative 1. See these points are plotting? Use the X head or use that dot and circle fancy thing. 2, 1, 3, 3. This is the plots from the table. If you bring up the table, a little bigger, you can actually see like the plots from the table, right? And then, bang. So it should form a straight line. Everything should be looking nice and proper. And this is your line. I'll label this. So let me just show you how you get how you secure the bag in this. It'll be like y is equal to 2x minus 3. That's the line. I put a title here, graph of y versus x, or they may have a title waiting for you. Put your x, you put your y, and there were no units to label in this. So other than that, you're good. So rate out of 10. How much you understand this? Keep this view on, because I'll just show them right here from my iPad. Using the graph, drawn in the part, determine the value of x when the line is equal to 2.2. So when is this line equal to 2.2? So what's supposed to happen is they're supposed to find 2.2 on the x and draw a line, touch the road, and then come down and read off the x. Y'all can do that? So where you think 2.2 will be here, boy? This is 2, this is 3, 5 divisions in between them. So every division is 0.2, right? So this is like 2.2 right there. And then you do the dotted line thing, and you come across. Sing a tune and thing, once you come across. And then when you hit the line, bang, like say we hit the line there, because I feel like where we hit it. You come down. And then you read off that. So what is that value there, folks? What's that value? This is 2. This is 3. So what do you think that is? That looking like a solid 2.6. That looking like a 2.6. 2.6, right? So, and I'll just write the answers here. When 2x minus 3 is equal to 2.2. So when the graph is 2.2, and I hit the graph, the x would be equal to, from graph, x is equal to 2.6. And there were no units given in these things. All right, enough of that. Let's do our next question. So you're bringing up slide number 5. Slide number 5, and I'm moving this overhead all the way. So consider the function. This is our next weird question, boy. So sometimes in question 8, they feel entitled, if you could, they feel entitled to bring up the they feel entitled to bring these weird questions. Like watch where that x is now. That's a kind of index thing. So technically, this is not on your syllabus. But the idea that they are testing is you being able to fill out the missing spots in a graph by substitution, which is on your syllabus. So you knowing about the graph not really on the syllabus, but that's small thing, right? So what's going to happen is that you do the same thing. When x is 0, y would be a half into 1 minus 0. 1 minus 0 is how much, folks? 1 minus 0 is 1. And anything to the power of 1 is a half. So this is half. And then when x is equal to 3, when x is equal to 3, y is equal to a half into 1 minus 3. So this is a half by negative 2, half to the power of negative 2, which is the same as if we reciprocate it. So we'll get 2 to the power of positive 2 squared, which is 4. You can put it in your calculator and see 4. And just like that, you finish that part of the question. So how was that for y'all? Y'all understood what went on there? We just substituted. We did this just before. We did the same thing just before. And then they want us to draw the graph of y versus x to represent 1 centimeter on the scale, blah, 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 and draw appropriate lines on your graph. So this graph will be a curve. This graph will come out like a curve. So let me actually do this graph digitally now that we had a take the time and show you how the graph page will look, right? But I'll do this graph digitally. Hey, I think I have a kind of graph thing here. I have a kind of graph thing here that will kind of substitute for graph page. Nah, bring up the grid. Listen, cutting it on 6. So we want to plot the graph of y is equal to half to the power of 1 minus x. Now remember, the key things when you have this graph in the exam is to look to see how far it's going. It going to the 0 and it going up to 5 on x. So x is like 0 to 5. That's no negative. And y is like basically 0, but going all the way up to 16. And then they want you to check when is 11. So 0 to 16 on the y and 0 to 5 on the x. So I wish I could have turned this portrait by. That'd be real good. That possible on your end? That'd be real good. If I could get a portrait. Now, I could just turn my iPad this way, but everybody across the Caribbean got to watch this video sideways. Are you mind if I do this like this? Are you mind if I do this like this? I want to turn the iPad and just do the graph that way now, but it will look way better. I'll bend on your head because when my class, when them sending homework and thing on Google Classroom and thing, them is be sending the thing sideways and thing, and my tutors had to be watching things sideways. So everybody getting a little sideways today. So that is my x-axis. It kind of bends, so I'm gonna sort it out a little bit. That is the x-axis. So because you all stayed for this live, even though the live was getting me real stress, I want to reward you all. I'm going to create a WhatsApp group, and I will show the invite here. So I'll be the first people in the WhatsApp group, and I'll be able to share experiences of CSEC 2023 and that kind of thing, and ask for help and whatever. All is doing WhatsApp. But you can't ask people for the phone number, and well, you can see phone number, but don't harass people and things. I gotta set some rules. Because some always does not know how to behave, boy. I'm a school teacher above everything else, you know. So I know some of them just do not know how to behave. They do not know how to behave. So I gotta set some rules in that WhatsApp group because I'll never be doing the will. And I'll set some moderators and all kind of thing. But it can be a useful WhatsApp group. I forget all the numbers for this thing, and I'm gonna tell you the X going from 0 to 5 and the Y going from 0 to 16. 0 to 5. So let me say we do 1, 2, 3, 4, 5. That's a problem. You lost in marks one time. Why you lost in marks? Because that's too tiny. You didn't make full use of the paper. So it'll be like 1, 2, 3, 4, 5. That looking a little more respectable. I'm trading 6 for kicks, so I don't need it. So 0 and wait now. 16 might work with this. 3, 4. And then the next one, 1, 2, 3, 4. And then the next one, 1, 2, 3, 4. And the next one, 1, 2. I must reach 20 or some kind of thing there already. When you see them little dots appearing on my pages, just that this thing real sensitive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18. Only up to 16 we need. And the graph went like this. The point was 0, 1/2, 1, 1. So 0 was 1/2. I'm going to use blue so you can really distinguish it. See that? 0 was 1/2. 1 was 1 year. What kind of rules do you feel I should put in our WhatsApp group? The next thing I want to do is, the next idea that I want to explore, let me just say I want to do. 2 was 2 is to have a Caribbean graduation. Well, I don't know if anybody from any other islands could actually make it to Trinidad. Have a graduation that everybody can attend. So 5, 16, and that is with it. That is with it. And then you connect the dots like this. I'm trying to find the undo button. I'll have to give me a chance with this one because real fight down to connect these dots, boy. Ooh, that come out pretty good. Yeah, he's a professional in the dance, long time. So you know, it's long time now doing this. Yeah, so this is the graph. Y is equal to 1/2 1 minus x. Fascinating. This is Y. This is X. The student hub grads. All right, so what next? That is it for 4 marks? That is it for 4 marks. You put in your scale, your art show you all how to spin the scale, and drawing appropriate lines on the graph, determine the value of x when the function is equal to 11, when it's equal to 11. So here's how you do that, right? I'm going to show it in, I know how much colors to pick from, so I can just go with that orange. 11. So what I'm going to do is draw a line across from 11. Oh, I show it to people right now, the laptop holding sideways. You're holding your laptop sideways doing this thing. Tag me if you're holding your laptop sideways and share it on Instagram. So 11, that is 11, and then you're coming down. I really wish that had hit there. Let me pretend that that hit there. Maybe that edge was supposed to hit there. And they come down. And that was 4.5. 4.5. 4.5. So from graph, x is equal to 4.5 when half 1 minus x is equal to 11. And that's UD. Let's go on to the next part of the question. Okay, so on slide 7, the question was actually pretty easy, although it had a weird function. On slide 7, something on a speed time graph. What's in the cup, sir? What's in the cup? It's just water, it's just water. This speed time graph below shows information on the first 12 seconds of a ball's journey. Calculate the acceleration in meters per second squared of the ball during the stage 1. Kind of tiny, but that's what I have written there. So we need to calculate the acceleration of the ball during stage 1. Acceleration during stage 1. So how do we get acceleration? It's a speed time graph. So on a speed time graph, and Saturday I'll show you the types of graphs that come, right? On a speed time graph, acceleration is the gradient, which in this case is, if I use these 2 points, stage 1, if I use these 2 points, using the point 0, 0, and let's call that A, and the point is that 4, 11. It's going to be y2 minus y1 over x2 minus x1, which is 11 minus 0 over 4 minus 0, which is 11 over 4, which is wherever that is. I don't really care. But just put make sure you put meters per second squared. Wait, let me check and make sure that the right unit seconds, and I see now kind of meters per second thing sneaking up there, so we good. We good? Yeah, we good. We good. Coconut Ramco gas. Just to be clear, these were the points I used, 0, 0, and that point up there. This is looking a little off, but we left. Complete the average speed of the ball during stage 1. Calculate the average speed. So the average speed is always going to be distance travel over time taken. Have another way to work out the average speed here. Use it. All the physics and maths people are pat down. Let me just use this normal thing. Distance travel over time taken. Somebody tell me this is 2.75 here, 2.75 meters per second square. So how do we get the distance? Because the distance wasn't given during the stage. The distance is the area underneath the graph. So since distance is area on the graph in a speed time graph, it's equal to base by height divided by 2. So it's 5 times, oh no, base by height. This is the base, 4. See now? 4 by 11. 4 by 11 divided by 2, which is 22 meters. Why is in the chat if you understand? You understand where I get the 4 and 11 from? Popular thing. So it's 22 over the time taken, and the time taken is 4. Because it's a triangle. I'm trying to get the area under this part of the graph here. And this is 4. This is 11. So it's 22 over 4. 22 over 4 at the end of the day. So 22 over 4 is, I don't know what that is. It's some kind of 5.5 something. So 5.5 meters per second. You can write your meters per second like that as well. At t equal 9 seconds, as here, so bang, the ball started to slow down with a uniform deceleration. How long did it take for the ball to come to rest? That 1 mark. So it took 12 minus 9 equal 3 seconds. So if this question come, by the way, if distance time or speed time graph come, my class had no excuse to lose a single mark there. The amount of time we grind this, in crash course, December, April, plus in class. Well, you're just supposed to be running through that question. So our next question on page 8, the functions f and g are defined as following: f of x is that, g of x is that, say the value of x for each function f is undefined. I do this already. Or is if a function undefined? When f of x is undefined, we have division by 0 taking place. And how we gonna get a division by 0? I mean, the denominator to be equal to 0. So therefore, 2 minus 3x must be equal to 0. So negative 3 must be equal to x over minus negative 2 when I bring across the 2. And x will be equal to negative 2 over negative 3. 2 negatives makes a positive 2/3. X must be equal to 2/3. So if I put x as 2/3 there, the 3 will cancel. And I'll get 2 minus 2 is equal to 0. I end up dividing by 0 and I bacchanal any quotes. Find an expression for f g of x. Let me squeeze it in here. F g of x. So g of x is 1. Yeah, they do the 1 closer to the x first. 1 minus 2x. And now you have to take g of x and stick it into f of x. So f of x, f g of x would be taking g of x and replacing x anytime you see x with g of x. That making sense for people here? Let me do a little color coding here. We're going back into primary school days. Let me do a little color coding. So this is f of g of x. You understand? So now I need to write f of x, which is really 5 over 2 minus 3x. But stop. Anywhere I see x, I need to put g of x, because that's how these compounding is. And g of x is 1 minus 2x. And then I just take my time, and now don't take your time. Do it fast. Do it fast and make sure you don't get it wrong. So 5 over 2 minus 3 by 1 is negative 3. Negative 3 by negative 2x is plus 6x. This good? This good? Thanks, Marissa. 2 minus 3 is negative 1 plus 6x, which is, you could also write this as 5 over 6x minus 1. We're going to use back the 2/3. No, I mean, that 2/3 was just the first. You never really use back this undefined thing. It undefined, the function is undefined. If that happens, you do what that happens. So you could only find a number and just leave that number there. So that we didn't have to use that back for any other parts of the question. And just like that, we finished. No, part 3. I just remember it had that day was yesterday that I leave out something. I'd go back and do it. I tell my class, everything blend together now. It's so much classes. 5 over 2 minus 3x. Let y be equal to f of x. So for y is equal to 5. This is an easy one. It didn't have x in 2 spots. Make interchange variables. So you get x is equal to, this is how you do the inverse, people. 2 minus 3y. Make y the subject of the formula. Yeah, everybody understanding? Nice. And then you'll have x into 2 minus 3y is equal to 5. And x by 2 is 2x, and x by is minus 3xy. You have to make y the subject of the formula is equal to 5. Bring across the 2x, 5 minus 2x. Then bring across the negative 3x, because you have the y by itself. 5 minus 2x over negative 3x. That's correct. And I'm looking so disastrous forward. Let's look at another extra. Interchange. I could do this faster. I could just do this swap and have 5 over x and then bring across the 2 and then divide everything by 3. Still get the same thing. So therefore, right. Therefore, f inverse of x is equal to 5 minus 2x over negative 3x. Squeeze it into the corner there. Yeah, this is step for inverse. You could look up the topic on my channel, finding the inverse of a function, and I'll break it down for you in a nice slow piece. So yeah, there's these 3 things you have to remember, and you have to just follow suit. Slide 9. I feel tired. I feel after slide 9 that is it now. Might even reach slide 15 today. I've a 12-hour crash course to do on Saturday. Who come up with whose brilliant idea was that? The rectangle ABC not drawn to scale is divided into a quadrilateral DEFC and 2 right angles, ADE and EBF. AED has an area, AED right has an area of 32. That's the triangle like this. This is 32 square meters. This is also 4x. And the whole thing is 5x plus 2. 5x plus 2. You understand how I get it, right? 5x plus 2 is this side. So, all right, not bad at all. Not bad at all. By writing an expression for the area of triangle AD, which is where I thought they would go with this, show that I feel rejuvenated with this question. So area of a triangle is equal to base by height divided by 2. So the base is, let's call the base 4x, and the height is, we already say it's 5x plus 2. Why did I put plus? I need to put multiply. Is base by height divided by 2. The 2 could go into that one time. So it's really is equal to 32, right? So it's really 2x by 5x, which is 10x squared. And 2x by 2 is 4x. So take your time and see if I'm doing things that make sense here. And then if I divide everything by 2, divide by 2, I'll get 5x squared plus 2x is equal to 16. And if I bring across the 16, 5x squared plus 2x minus 16 is equal to 0, which is what I wanted to show in the first place. That's what I wanted to show in the first place, boy. So calculate the value of x. That's a quadratic, or you could do that. Calculate the area of the quadrilateral. So after you figure out what x is, you're going to substitute back x and find the area of the quadrilateral. Easy man thing. Easy we do it. So we want to slide 10 to get a new place to do this thing. We don't need to see that diagram again. The only thing we need to see is the quadratic. All right. So calculate the value of x. So 5x squared plus, do you know you can solve quadratic on your calculator? Look it up after this video. How to solve a quadratic on and write your calculator. So 5x squared plus 2x minus 16 is equal to 0. This might be a quadratic to solve on your calculator, because who really want to multiply 5 by 16 and figure out all these things? 5 by 16 is how much money? 80. 5 by 16 is 80. 2 numbers I'll multiply to give me 80, but add to give me 2. 10 by 8. 10 by 8. Positive 10. So you put 5x squared plus 10x and minus 8x minus 16 equals 0. And then you put 5x into x plus 2. Pay x plus 2 there equals 0. Then you put negative 2. So you have 5x minus 2 into x plus 2 equals 0. So either 5x minus 2 is equal to 0. So you'll end up with x is equal to 2/5. Or x plus 2 is equal to 0. So x is equal to negative 2. Got that, class? Why in the chat just mean yes, you know? So I'll don't get frightened if I see 1,000 people playing why in the chat. Calculate the value of, wait. This one is invalid. X must be positive. Is 8. Is 8. Where I get 2 from? 8. Is 8. Yeah. So x must be positive. Therefore, x is equal to 8 over 5. Yeah, it's 8. Remember, I've had to factorize out 8 there. So it's 5x minus 8, so I end up with 8 over 5. So x is 8 over 5, and then use that knowledge to find the area of the quadrilateral DEFC. But the quadrilateral, if you go back, how much x's we have here? We have 7 x's here, and then we have 5 x's plus a 2. Understand? So the quadrilateral is 7x, and then it's 5x plus 2. Let's go back to the slide 10. So the area will have to be 7x multiplied by 5x plus 2, which is length by breadth, right? And we know what x is. X is 8 over 5. 5 by 8 over 5. Well, hey, 7 was correct. 7 was correct. Yeah, 4x plus 3x. That's 2. So it's 10. 5 will cancel into the 10. I make 2. So it's 7 by 8. 56 times 2. 112. I guess in 112. All of that will work out to 100. And anybody confirmed with me? 112 meters squared. So tell me if I get that. Those of you all who watching in the past, so let me know in the comments, was it correct? 112 meters squared. After you done substitute all the x and thing and you work out the area. Nice. Solve the pair of simultaneous equations. It's still a more, boy. It's still a more. Let me ignore this question. Let me ignore. All right. Are you want me to do this question? Are you understand this question? Do this question still? Or just jump into the completing the square? Because I really wanted to get a completing the square done today. Talk to me. What are you for? Yes, why, well, yes, no ship, yes, complete the square, do it. How are you have so much stamina? So are you getting on like maths exam is next week? If maths exam was next week, Ali would not have been here. Or no, would you? All right. So let me do it then. The people say let me do it. So this is the same kind of substitution vibe. In this question, I would substitute for y though. Substituting for y is the better thing in this question. So let me say I have 2x is equal to 6 minus y. So bring across the y, I'll get y is equal to 6 minus 2x. You'll see that? And then I'll substitute for y in equation 2. We call this equation 1. And so I will, instead of putting y, I'll put 6 minus 2x minus the x squared. I replace the y plus x is equal to 6. So I'll have 6 minus 2x minus x squared plus x is equal to 6. All right, but the same thing for y. So I'll get 6 minus x squared is equal to 6. But the factor has 6 on both sides. What that's supposed to mean? I mean, I could just drop it. So I just really have negative x minus x squared is equal to 0. I'll double check that and see if that sounding good. So these are the really hard simultaneous equations. Well, really hard. It's kind of easy still, but it's hard for CXC level, right? That y'all may encounter in the question 8, and you need to make one of the variables the subject of the formula and substitute into the equation of the substitute into the next equation. So making y the subject of the formula, I found that y is equal to 6 minus x, right? 6 minus 2x. And now I want to take that 6 minus 2x and replace it there. So 6 minus 2x, and there's nothing to multiply or expand, so I just drop the brackets. And the 6 here, if I bring across that 6 to negative, the 6 will cancel, so I can just get rid of the 6. And then negative 2x plus x is negative x, and minus x squared, still there, minus x squared. So this is IB right here. That we ready. Did I tell you to solve anything? Oh, solve. Oh, yeah, solve. So this is x into x minus x into, I want to say y. I could say negative x2. Or I could say x into negative 1 minus x, if I want to do it that way, equals 0. So either x is 0 or no, Murray says one of our students. Or x, negative 1 minus x is equal to 0. So negative x is equal to 1. So x is equal to negative 1. So either you will get x equals to negative 1 or x equals to 0, and then you need to substitute it back into the y to itself. That's why it's 4 marks. It's a lot. You can't use the matrix method for this because you can't use the matrix method for this. You use the matrix method if it's too linear. The CSEC matrix method. So what I want to say by? I want to substitute when x is equal to 0, y would have to be equal to 6 minus 2 by 0, which is 6. And when x is equal to negative 1, y would have to be 6. Or pen like it running out of charge. Y is equal to 6 minus 2 by negative 1. Where I get this equation from? I get it from here. So 6 plus 2 is 8. So a little me are going too fast now. First I'm going too slow, now I'm going too fast. So if you need a little slow down, you can always come back and watch the video and pause and do it and then catch up and pause and thing. But I want to do some more questions, so I keep chatting at a certain speed. And if you want to revise this specific topic, this is called simultaneous equations when it have linear and non-linear. It's not the normal kind of simultaneous equations, it's a tough one. So I'm going to form the WhatsApp group just now, right? So here we go, form the WhatsApp group, and tomorrow I'll give you the link. Tomorrow I'll give you the link. Or I'll post it on my Instagram story. I'll post it on my Instagram story. Or someone on Instagram, or it's supposed to be on Instagram. Tomorrow I get. What's the next part of the question? I grow tired. I feel weary. But I must continue. I want to pull up a next slide. The next part of the question was the completing the square, which I really wanted to get to. So I'll just do this part of the question and we'll mash your breaks here, right? So blessings. So for this, completing the square, what I have on YouTube is I have the natural perfect square method and I have a formula method. And the reason I put the formula method and popularize the formula method is so that folks who have problems completing the square, which could be a little tough for, you're no big boy in maths here. It could be tough. At least you could complete the square and be able to get all the marks in the other parts of the questions and things. So the formula method is really good. So I'm going to show you 3 methods now. I didn't really show much of the comparing the coefficients method in the completing the square video that I did back in 2018 or whenever. So I want to show you 3 methods for completing the square, and we're going to call that George for today. And y'all can go and research this. The first, I'll do it in decreasing order of difficulty. So I'll start off with the toughest one first. And here's the thing. Although it's the toughest one, if you understand it, it becomes the easiest one because it's just 3 lines. The formula method is the easiest one, but is a good bit of work to do. So there we go. So the easiest method to complete this square is to create a perfect square. Actually, just complete the square. And when you say create a perfect square, they mean a square like this. Let me say x minus 9 to be squared, or 2x minus 3. They don't even want it 2. Although that'll still be a perfect square, like x plus 3 to be squared. All of these are perfect squares. And why are they perfect squares? Because they will perfectly form a square with two sides, x plus 3, x plus 3. A quadratic is a square too, you know, but it's not perfect because it had these little extra little or something in them there. So what we notice is that perfect squares create a certain pattern. So this method that I'm going to do is forcing it to create the pattern so I can factorize it into a perfect square. That may sound like it didn't mean no sense to you, but let me show you. So 3x squared plus 9x plus 5. First step is to pull out or whip out. I don't really want to use the word factorize. Factorize will make you feel you need to get it from everybody. But it's like you're factorizing it, but from the first two terms. So 3 into x squared plus 3x. Now, I put... One thing I always laugh at, I put in the video that is really popular on YouTube, I said, whip out the A. I have it in nice little steps to help students remember. And now a lot of school teachers are saying whip out the A, and I know I said that specific phrase back then. All right, so whip out the A. So 3 into x squared plus 3x. 1x. The next thing is the critical piece. This next line here is the line from line land. This is the line that most people don't understand, and this is why most people have to use the formula method. In this line, you are trying to make a perfect square, unfactorized. And to make a perfect square, you need to get half of this and square it and drop it in. Half of this, not the b. This is b, b is 9. You remember you factorized out a out of the b. So you want to get half of this, what is left behind, and square it. And if it all remained in whole numbers, it would have been easy, but it usually goes into the land of fractions. And I'll just show what's happening in my mind. So half of 3 is 3 and 2. You don't put 1.5. You don't deal with decimals in this. You leave it as an improper fraction. So I find half of it, and then I square it. So I have 3 over 2 squared, which is 9 over 4. Right? If you all wanted it even slower than this and break down and somebody holding your hand and spoon feeding you the porridge and blowing the porridge before they give you it and thing, just go and watch the video that I have on it. You can get to see it in detail, right? So I'm going to add this number in. That's what I'm going to do, folks. 3x squared plus 3x plus 9 over 4. Brilliant. Close up the brackets and plus 5. Now the thing is, we just treat a random number in equation. You can't do that. So one of the weirdest things, but it's also a very useful little technique that we do in mathematics. For example, if I told you x is equal to 10, and then I say, well, x plus 2. Since I just train a random 2 here, I'd train a 2 there. X is 10 plus 2. So x plus 2 had to be equal to 12. So since I train a number, I need to throw it in on that side. Or now this is the part that might catch some people. If I said x minus 10 is equal to 0, that means x is 10, right? You can see that, right? X is 10. 10 minus 10 is equal to 0. So if I train something, x minus 10 plus 2 is equal, and I still have equal to 0, I need to take back out that 2. So I put in this 9 over 4, and I need to take it back out so that the equation maintains its true value. So I put in the 9 over 4 and I need to take it back out. But there's more. I don't really take out 9 over 4 because I didn't really put in 9 over 4. What do you think I really put in here? I put in 9 over 4 multiplied by 3. So since I put in 9 over 4 multiplied by 3, I need to take out 9 over 4 multiplied by 3. So 9 over 4 multiplied by 3 is actually 27 over 4. You could put it in your calculator and see. 3 by 9 is 27, right? That's where we end up. And now, this is a perfect square, so the last line is the ending line. And the ending line, you're going to use half of this, which we have, the square root of this, sorry, which we have, which is plus 3 over 2. Make that a nice little square there, and resolve this. What is 5 minus 27 over 4? 5 minus 27 over 4 is what? Well, I could think of 5 as 20 over 4. So 20 over 4 minus 27 over 4 is negative 7 over 4. Yeah? So that's the answer there. No, so that's method 1. Are you like that method? How many of you all follow that method true and true? Everything about that method was just making you feel warm and fuzzy inside. You just make my page bigger. Oh, my page was always that size? Yes, my page just magically get bigger. What? The magic, boy. So you can just follow me around and zoom in a little bit where you need. So 1. So that's method 1. Let's try method 2. We're going in decreasing order of difficulty, right? So method 2 is comparing the coefficients. I don't really have this method on YouTube open. I might have it in some crash course video or some kind of thing somewhere. So comparing the coefficients is another useful method that will always give you full marks. So you have 3x squared plus 9x plus 5 is equal to a into x plus h to b squared plus k. So another method to complete these squares is that you equate the quadratic with what you want and then you expand. So expand the right-hand side. So if I expand the right-hand side, I'll get a, and this is x plus h to b squared. So this is really x squared plus 2xh plus h plus k. Plus 8 squared, sorry, plus k. So far, so good. And this over here is 3x squared plus 9. You just leave this the same. 3x squared. Let me put it back in red. So what is the aim in this, boy? We didn't quite reach where I could show you what the aim in this is yet. So let me just do one more line. One more line, folks. 9x plus 5 is equal to a into x squared. I want to write this one in blue still. Let's say a into x squared, because I'm expanding with the a. 2ahx. I want to bring the h here. I only want the x's to be the ending. Plus ah squared plus k. So pay close attention to this. I am saying that this, anybody ever do this method? I'm saying that this side is equal to this side. So if this is exactly the same as this, it means the number in front of x squared must be a. So we just immediately figure out what a is, which we know anyhow, because a remains the same even when you complete the square. So a, therefore, so you need to write this, because this is what you're doing, comparing coefficients. Comparing coefficients. Coefficients means the number in front of the letter. A is equal to 3. Now, the number in front of x is 9, but what in front of x here? Here, over on the right-hand side, 2ah. So we must say 2ah is equal to 9. But a we know as 3. So 2 by 3 by h is equal to 9. So h is equal to 9 over 2 by 3 is 6. 9 over 6 is the same as 3 over 2. Now, if we were to come out of this, zoom out a little bit, and go over back to our good friend, which we do, the perfect square method, you would see that we got that 3 over 2 for h, because this is in the form, which is usually how we finish off this, in the form a into x plus h to b squared plus k, where h is 3 over 2. You see, in h is 3 over 2. So we're going good. We know we're going good. So let's go back to the comparing the coefficient method. One more thing to figure out. This whole piece here must be equal to 5, because this is just a number by itself. It has no x in here, so this just represents a number and it must be equal to 5. So I would say that, well, ah squared plus k must be equal to 5, but I know what a is. A is 3. I know what h is. H is 3 over 2. So 3 over 2 squared is 9 over 4 plus k. K is equal to, k is what we're trying to find. So k is equal to 5 minus 3 by 9 over, which is the same thing we do now, minus 27 over 4, which is, k is negative 7 over 4. And we just figure out k like that. So what y'all think, boy? What do you think about this method? And then you write, therefore, the whole equation is equal to 3. Back in the days, this was a pretty popular method, and a plus 3 over 2 to b squared minus 7 over 4. It was a pretty popular method. Last method. Do I have space to put this last method? Anyway, I don't. I really didn't want to go on to the next slide, but it seems like I have no other choice. Let's go on to slide 13. The last method, my friends. Where this question is, man. You know, I can't find back the question. Oh yeah, I found it. The last method for completing the square is the easiest method. And everybody, if you can't do one method, the first method you should learn how to do is this method, right? Even if you're in Form 4 and you're just watching this for kicks. First method is this one. So if I have 3x squared plus 9x plus 5, for this method, you need to memorize two things. You need to know that h is always going to be equal to b over 2a, and that k is always going to be equal to 4ac minus b squared over 4a. Or, you might see me have this in the video, c minus b squared over 4a. Right? So it's always going to be equal to b over, h going to be equal to b over 2a, or k being equal to that formula. So you have to memorize those two formulas, one for k and the formula for h. And then you substitute. And that's all. So everybody knows to substitute. Therefore, h is, b is 9, 2 is 2, and a is 3. So this is 9 over 6, which is the same as 3 over 2, which we already know h is because we get it twice already. And k is equal to 4ac, 4 by 3. And by c is 5 minus 9 squared over 4 by 3. Put this whole thing in your calculator. And I assure you, you will just get a nice negative 7 over 4. And then you're done. And then you say, therefore, the whole equation, let's say the whole equation, 3x squared plus 9x plus 5 is equal to a is 3x plus h is 3 over 2. We just figured that out to be squared minus 7 over 4, right? And you usually write where a is 3, h is 3 over 2, and k is k. K is negative 7 over 4. So this is the third method. You know what? Since all it was so nice, let me give you one more method. The easiest method of them all. So zoom into the, oh no, I need to bring the overhead camera back in the game here. Watch this. Yeah. See, we see it in my iPad there, right? The easiest method of them all is the calculator method. But for this method, you must have it accompanied by another method. So this is a method to just verify that it was going along the path of righteousness. So how does this work? What you need to do, press mode on your calculator, and you have this kind of calculator, a calculator similar to this. Press equation. This is simultaneous equations. You can do it on your calculator. If you want to see how to do it on a sharp, look up Kerwin-Springer-Sharp quadratic or Kerwin-Springer-Sharp simultaneous equations. I'll show you how to do it on all the types of calculators. Well, Sharp and Casio. This is the one I want. Ax squared plus bx plus c. Everybody know that that is the general form of a quadratic. So I'm going to press 3. And now I must put in these numbers. 3, 9, 5. 3, I'm typing 3. See it pop up there? Press equal. 9. Then press equal. 5. That's a 5 there. Press equal. Equal is like enter. And then if I press equal one more time, it solved the equation for me. This is a number. If I press SD, I'll get the decimal, the answer. So it basically solved the quadratic. If it was a quadratic that could factorize easily, you'd get x is equal to 3 or x equal to 1, whatever it is, right? But it's a kind of weird quadratic. So you get this wildness. Press equal again. And give me the next x value. Press equal again. Guess who? The value of the minimum point. But we should know from completing this square that the minimum point is nothing but The minimum point is nothing but negative h. So since this is true, negative 3 over 2, we know h must be 3 over 2. So you could verify how to complete this square in your calculator. Please watch this. Please go and practice this. So if you get this in the exam, you could help yourself to some free marks here, man. Or at least be sure that your working is correct. And what is this? This is k. The y value at the minimum point is always directly equal to k. The x value is negative h, but the y value is just k. So negative 7 over 4, which is what we got like 3 times with the 3 methods. By the way, I basically just help myself. So bring back up the digital board. I basically just help myself to the answers here because they say state the minimum value of f of x, which is the minimum value of y if you have y equal f of x, which is k. This is the minimum value of f of x is k, which is negative 7 over 4. And determine the equation of the axis of symmetry. Axis of symmetry is always going to be equal to, the axis of symmetry is always going to be equal, x is negative h. And you just literally have to write x is equal to negative h. And what is h? 3 over 2. So x is equal to negative 3 over 2. This is our equation. This is, so if the curve is look like this equation is passed through the point, remember when I was doing this, negative 3 over 2. So this is the axis of symmetry. It will split the quadratic into 2. All right, folks, we had to bring down the curtain here. I have some more questions in these, but these last, after this are 2 more sessions. And they take a little longer, and I won't be able to do as much questions because they go for 12 marks compared to the earlier questions, which just go for 9 marks, and it's the tougher part, right? So now that you know your calculator can help you out in this, go and experiment with it. Look up Kerwin-Springer calculator. Sharp, most of you all have the Sharp. Or you can look up Kerwin-Springer Casio. Casio is superior. And you'll be able to see what your calculator can help you with in the exam. And with that, we want to say love and blessings. Look out for the WhatsApp group. I want to create that before I might do it in the live. I have a live. We have the student have live at 6. Yeah, I would be ready to do it in the live. So we'll create the WhatsApp group and you could converse and things. Let me see. We could get a couple hundred in that WhatsApp group. I think WhatsApp have a limit to how much people can be in it. So jump in fast. All right. Love and blessings, people.